about having the equivalence, which is the quality coding. The second is about the continuous feedback mechanism, which is the CDF. We talked about things like tools like Sonar. The third and the very, very important aspect here is how should we approach code? How should we start writing good code? What is a way that we follow that it can result into good code coverage as well as good quality code? So my recommendation here, or what we have followed in Sapien, and then what we recommend is that one great way of doing that is following test-driven development. So I'll be talking about test-driven development in the next slide, but I'll also try to again hook this story to the story which we had, wherein the kid who was a developer who wanted to basically become a good cricketer. Yeah. So the kid actually had equipment. He is now able to get feedback, but now he wants to understand what are the best shot, how he should play, and he actually needs some coaching. So he needs a coach basically. He assigns, so there is a coach assigned to him, and then he starts learning the good way of doing it. Similarly, in our world, this actually role is played by a test-driven development. So test-driven development is a shift from our conventional mindset, wherein you first write code, and then you write a test, and then you write a test to basically test it. In this approach, what we do is that we first write a test, then we write a code, and then we actually refactor that, and then we keep doing it until a point that we can't think of any more tests. So few people can argue that what exactly is this, right? So what is this way of doing it? Why? How can I write test and then I can write code, and then why should I do it? The reason for this paradigm shift of mindset is that more or less a lot of us have moved to an agile way of development, and that means that you have to start working in sprints or iterations. That could be as low as 3 weeks or 4 weeks. And what happens is that whenever, so if you are developing a code for a 3-week sprint, then you will be given functional use cases, and based upon that use cases you have to develop code. The problem with the conventional way of coding is that if you are just trying to write code first and then you write test, you actually either write something which is not required, or you may write something which is required, but then it is more than required. So there is it is a difficult thing to basically maintain that sanity that you just write what is required. So that is why what you do is that you just read your functional test case, and based upon that domain understanding, you start write a code or a test case which says that what exactly are you trying to do. The moment you do that, you are actually trying to have your head fixed to the domain, and then you actually write the correct and the required code. So if you see on the screen, I have mentioned that core of test-driven development is you write a test case, then you think about what you have to write in terms of code. You make sure that you think about, and then you make sure that it actually fails first, so that there is no chances of that you have written something which is ambiguous or which could have dual meaning. By dual meaning, I mean to say is that maybe that you have written a code which actually passes not being the correct scenario. So you don't, in order to move from that point, you have to make sure that your test first fails. Then you make sure that your test passes, and then the other important thing to notice will be that you have to think about refactoring your code. You can never write, as a developer, you will never be able to write a code which is up to production standard at the first go. Do not worry about it. Write a functional code. However, even if it's spelling, don't worry about it. Write something, and then you keep refactoring about it. And then tools like static tools like FXCOP, CellCOP will help you, and then the dynamic process which I defined about earlier, refactoring patterns will also help you. So this is the way to approach it. The overall mindset of TDD is all code is guilty until proven that it is innocent, which means that do not do not assume that this particular code I've written that it will work until and unless there's a test which actually tests it and it should pass. There are several benefits which are actually available from it. TDD in itself is a very vast topic, and probably next sessions probably we can speak about it also. But what I want everyone to be, whoever is available here and listening to it, to think about that. If you want to follow an agile methodology, if you want to basically write covered code, then you should think about following TDD. It actually improves your quality. Very important thing to note here would be that it improves your code design, because you are now thinking about your domain or the functional aspect. Then you actually create a design which is very appropriate and close to what is required of the software, and it often results into high test coverage, because you are first writing code and then code. So more or less what my experience has been that it's about 100% code coverage if you follow TDD. So TDD concept is very good